Hello and welcome to the Data Cleaning Overview powered by Award Solutions. My name is Reece, technologist at Award Solutions and host of this complimentary webinar. In this session, we're going to give an overview of data cleaning, principles of data cleaning, and we're going to provide a data cleaning example. As I said, my name is Reece. I've been with Award Solutions for 19 years. Been in the telecom industry for a little over 28, and my instructional focus is artificial intelligence, automation, network transformation, 5G wireless, consulting, as well as custom training, and it's an honor to be with you here today. Award Solutions is a proven leader in technology training with over 20 years of experience. We will be presenting at both CCA and Mobile World Congress coming in February and March of 2020, as well as a number of other events throughout the year. I also want to let you know that we are recording this session and we'll send an email with a link to the recording within the next couple of days. We've reserved some time at the end of our session today for Q&A. At any time, please go into the chat and ask questions, and I'll try to answer them either as we're doing the presentation or at the end of our time together today. I want to thank you for investing your valuable time in this webinar today. And as a special thank you, what I'd like to do is to give you a discount on some additional on-demand training. Our entire portfolio, if you use the coupon code DEC25, is at 40% off through the end of the year. Let's jump into our topic at hand. My objectives for today are really threefold. I want to talk a little bit about what data cleaning is and why it's so important. I want to spend a little bit of time walking through some of the principles of data cleaning. And then lastly, I want to provide an example of data cleaning. So what I've done is I've put together a Jupyter notebook that has a very simplistic data cleaning example, just so we can see it in action. So let's get started with what is data cleaning. Well, data cleaning is part of a bigger concept that we like to refer to as individual automation here at Award Solutions. We believe that automation is something that's not just for a select number of people to do, but it's for everybody to do to make their job more efficient. At Award Solutions, we have a concept we like to call a define in 9, a definition in 9 words or less of a fairly technical topic. Our definition of individual automation are individuals leveraging software and automation to increase their effectiveness. And there's 2 key things to this that I think are important. The first is we're trying to use software. We're trying to have something that we can use Python or some other automation software to do some type of improvement of. And specifically, we're trying to automate to increase our individual effectiveness. I am a firm believer that automation is a necessity, only because as our networks become more and more complicated, as our systems become more and more complicated, as we have more and more pieces of equipment that we need to monitor and track and manage, we need to be able to do more with less time. The only way we're going to do that is through automation. And if you haven't had a chance to really take a look at a 5G network, in 5G, we're going to see a huge increase in the number of elements that we need to manage. How do we do that if we don't have some type of automation? So if we take a step back, our goal is fundamentally this. We've got a lot of information, and that's what I'm representing with all of the objects here at the top of this graphic. And this can include things like logs, counters, alarms, status, as well as things that we don't typically think about. It might include things like social media or customer complaints. But we have a lot of different sources of data. And what we want to do is we want to put that into some form of automation package. We're going to look at an example of Python in our time together today. And we want to be able to take that into some type of what I like to refer to as an insights dashboard. I want to be able to take all of this information and visualize it. I want to be able to graphically present it in such a way that I can be able to get some insights out of it. So let's look at a day in the life of a service provider employee with respect to gaining some insights from this data. The first thing we need to do is we need to be able to identify our sources of the data. This is typically pretty easy for us to do if we've spent any time within the industry, because we've been using this data. We've been pulling this data manually. So we know the data that we want. We'll then collect that data. We need to clean our data, which is our focus of our time together today, so that we can analyze it, visualize the data with really the goal of some type of insight and action. If we're not able to get to some type of action, we're really wasting our time. We need to be able to take some tangible action on this. Now, what we'd like to do is we'd like to take this and not do this in a manual form. We would like this part here to be done through automation. We're going to focus on that cleaning part. Again, the goal we have is that insight dashboard. We want to be able to visualize this data so we can see a large volume of data very quickly, and then we want to be able to filter it on the stuff that's really important. In this example, we can show a couple of things. One, in our network status that we see in the lower left-hand corner, what we have is a number of states that are having some problem. And so we could then start to drill down and see what those issues are. In the upper right-hand corner, we're starting to see equipment that may have issues that need to be taken care of. And in the lower center, we can actually see a set of alarms that we need to take some actions on. So this isn't necessarily new information. These are the types of information we've been looking at for a while. What we're trying to do is to speed up the process to get to this point in a more automated fashion. So data cleaning is needed so that I can pull all of this data from all of these different sources, merge it together into something that's going to allow me to visualize it and then take some actions. And that is data cleaning in a nutshell. Our second task is to actually do the data cleaning itself. And this is where we're taking data and we're starting to move it into a form that we could do some type of analysis of. And if we think about the nature of data, there's a lot of different type of data that we might have. They might be in different formats. They might come from different tools. How do we get all of that data into the same form so that we can do some type of analysis on it? That's really the key objective of the data cleaning process. So let's think about this first of the different types of sources of data that we might have. We might have our traditional telecom equipment. And as we think about this traditional telecom equipment, we need to think about, is it modern equipment or is it older equipment that we may have to get this in different ways? Maybe we're pulling data from an SQL database. Maybe we're pulling data from some legacy piece of equipment. Or maybe we're pulling this from our operation support system, business support system. So think about your network, or think about the network you're trying to manage, and think, what are the different types of equipment you may need to pull data from, and how do I get that data? The second thing to keep in mind is, what is the mechanism that we use to actually pull that data? Maybe I'm using some type of an API. Maybe I'm doing a simple SQL query. Maybe what I'm having to do is SSH to a node and pull down a log file. Or maybe I'm having to have the OSS and BSS push me some data periodically. This data could come in all different types of forms as well. For example, I might get my data as a comma-separated data. I might have a text data. It might be in some type of text log file. And so now what I need to do is I need to pull this data in and somehow massage that data to where it's something that I can use. All right. So one more slide with respect to what we need to do to actually process the data. So we've talked a little bit about sources of the data, mechanism that I can get the data, and now we're talking formats the data may come in. Let's talk about the nature of the data itself. So there's three basic types of data in which we have. We could have nominal data, ordinal data, or some type of ratio data, numeric data. So we can draw a line here, and we can separate this into really two categories. We have numeric, and we have non-numeric. Numeric is easy. Numeric data is numeric data. It might be a float, it might be an integer, it might have two significant digits, it might have no significant digits. It might be some other calculation. It might be things like sales revenue, weight, height, elevation, number of call attempts, number of call failures, number of packets that have been lost. Anything that is calculated, anything that is the form of a number. This is easy, we're not going to worry about this too much. But what about our non-numeric data? Our non-numeric data can really come into two basic categories. It can be nominal or ordinal. And really what this is saying is there some type of an order to this data? So ordinal has an order to it. Nominal, no order. So if I were doing some type of basic study where I wanted to say, look at subscribers' behavior, and one of the characteristics of the subscriber is, are they male or female? Well, that would be an example of nominal. I need to track that. I need to know, okay, is this a female subscriber doing these things or a male subscriber? Because that could give me some interesting insight. But there's not really a priority to that. Ordinal, on the other hand, is going to be something that's non-numeric, but has some order to it. So for example, I might say a grade that a student receives is an A, B, C, D, or F. Okay, well, A is better than B, B is better than D, and so on. So there's an order to that. I can say things about education. I could say based off of other thresholds, there may be some type of a ordinal characteristic to this data. Now, the reason I'm going through this and the reason that this is important is because what we're going to see here in a few minutes is I can't use non-numeric data as part of a study. I somehow need to convert this to numeric data. And so really what we're talking about here is we're talking about What's the process to look at this data in order to see how to convert the data? And we'll talk a little bit more about that here in a minute when we start looking at doing that conversion. Okay? One more. And we've talked a little bit about this. Our data, we can think of things with regards as either being discrete or continuous. Discrete data typically has some finite discrete members to a set. And so you could think things like product categories. You could think of regions, states, city. And so I might say cities in Texas. I'm based out of Texas. Or we might say states of the United States. Or we might say countries represented in the 2020 Olympics. Whatever the case may be, that is a set, that's a discrete set of members, not an infinite set. When we're talking about continuous data, what we're saying is there is no finite set. It could really be anything. Things like sales, profit, discount. In our telecom space, that might be calls, packets, errors. The type of error is going to be discrete. Now, what we're really talking about with everything we've said so far with respect to our data cleaning is we need to have a domain expertise. This is the part of the analysis in which we need to have an understanding of the data itself. And so if you were to come to me and say, hey, I want to do a study within the telecom industry, great. We would have to look at the documentation of that equipment. We'd have to get an understanding of what that data really means. If we're looking at something in the medical industry, or we're looking at something in the retail industry, or we're looking at something within the travel industry, we need to have an understanding of what that data means. So kind of a case in point, when I was at Nortel many, many years ago, prior to coming to Award Solutions, my job was to do capacity and performance. And we had an issue where all of a sudden, one day, the number of calls that our switch reported dropped by 30%. And I thought that was kind of weird. Why all of a sudden would we have the same amount of activity, the same amount of CPU utilization, but 30% fewer calls? Come to find out, what happened was somebody had moved a counter and the data was bad. So instead of the counter being incremented at one point in the code, it was incremented at a different point in the code. The only reason we spotted that was because we had domain expertise and we knew what to expect. Simple as that. Okay, so we've collected the data. There are different file formats. We have looked at the nature of that data. We've seen if it's discrete or continuous or ordinal or nominal. And now what we're going to do is we're going to actually go through a process of cleaning the data itself. And as part of cleaning the data, another term that's used is something called data wrangling. And if you're not familiar with the term wrangling, it's a term that comes from the South. I grew up in the southern United States, and it's more of a cowboy term. And think of it like, wrangling an animal, wrangling a horse. It's trying to control it so that you can get the results that you need. So there's 4 basic steps to data cleaning or data wrangling. And depending on the nature of the different systems you're trying to pull this data from, there may be different problems that you have to uncover. But basically, it's in 5 basic categories. The first thing is, I need to figure out how to deal with missing data. So every system is going to be slightly different. And there may be data that's missing. It may be missing because of some type of a corruption. It may be missing because of just the fact that the system will sometimes lose data. I've yet to see any data set that didn't have at least some missing data. The second thing we need to deal with is we need to align the data formats. And the biggest piece of this is dealing with things like strings. So sometimes when we read the numbers in, they come into a format as a string. Well, we can't do math on a string. What I need to be able to do is convert it into a numeric format so that I can do the appropriate math. So how do I get all of my formats the same? Now, depending on the nature of the problem that you're trying to solve, we might need to merge data sources. And we see this a lot when we're trying to pull data from different systems. We're trying to pull data from 2 or 3 different pieces of equipment and try to align them in some way. We'll typically have some type of a key that we need to use and pull data from different systems based off of that key. That key could be a phone number, it could be an IMSI, it could be some type of a call ID, it could be many, many different things. It depends on the nature of the data. And that goes again back to that understanding, that domain expertise. Okay, we need to remove missing data or clean, repair the missing data in some way. We need to align the data formats to make sure that everything can come together and we can do math on it. We need to merge data sources, convert strings to numerical formats as needed is the next step. So kind of a little bit of an overlap I had here. I probably gave not the best example for number 2, but what I'm talking about here is really doing that conversion. And one of the things I've seen on a regular basis is depending on the nature of the tool and depending on the nature of the data, I might even need to do things like convert from scientific notation to an integer or a float. And then lastly, we need to do some form of data summarization. And really what the data summarization is all about, it's some type of small, simple data visualization to make sure we understand what's going on with this data. So this is the process of wrangling our data. So let's go through and let's look at a couple of examples kind of in graphical form before we actually go through this in an example using real data. So here's a simple example where we need to deal with some missing data. So in this graphic, what I've done is I've pulled some graphic that's from a simple analysis that a lot of people look at when they're trying to learn AI and automation techniques, and this is referred to as churn data. So this simple data is data that describes individual subscribers, and then it says, is somebody going to, or is this particular subscriber, have they churned to another service provider? If yes, okay, cool. If no, great. And what we want to do is see if we can learn why someone churned, or what is the nature of someone who churns, and see if we can prevent that churning from happening. So in this particular case, I've got a column that's the number of voicemail messages. And you'll see that it's circled in red, and there's no data there. So in the original data, this was missing. So there's 3 basic approaches to fixing missing data. And in this example, I only have this one spot. I could have this all over the place in many different columns. But in this particular example, I only have this one spot that has missing data. So what can I do about it? Well, I've got 3 basic approaches. The first approach is I could delete the data sample altogether. In deleting the data sample, the reason that this is a valuable thing to consider is that I'm removing any bad data from my set. But as you can imagine, The other side of that is I'm removing data from my data set. And that may not be good, especially if I have a small amount of data. So what I can do is, first I can delete that data sample. What I might do instead is, instead of deleting the data sample, what I might do is come in and say, well, no, I'm not going to delete it. I'm going to set it to 0, as we see in step 2. I may not like 0 as my answer, so I may set it to something else, some other value. And a common one is the average of all of the other values in this column. Again, it goes back to, what is the nature of the data? In this particular set of data, probably what I would do is I would delete the data sample. But in other examples, I might want to replace it with something else, maybe a 0, maybe some other value. So there's another data set that's very commonly looked at, which is a house price data set. In that one, I wouldn't want to set the value to 0. I probably would want to set it to the average of the other house prices or something like that. So there's our first step. We need to remove any missing data. We need to clean the missing data. We need to either replace it with something else or delete the data samples. Depending on the source of this data, this could be quite a bit of data that we have to do this with. 2, we need to align our data formats. And in this case, what I'm really wanting to think about is, how do I convert an ordinal or nominal to numeric? That's really the problem I'm trying to solve. As well as dealing with just the numeric format itself. So let's look at this example. So this is a very simple example, just kind of a silly example, where we're trying to do an analysis that says, what is the relationship between somebody's salary, the distance they drive to get to work, and their height? And yes, I agree, this is a silly example. I've never seen anybody actually do a study that marked people's height versus their salary. It would be kind of an interesting thing to look at, but I've not seen that. So in this case, how would I want to do this conversion? So I've got 3 different, pretty distinct formats. I've got something that's a simple numeric, 5520. I've got something that's more of an ordinal, low salary, medium salary, high salary, number of dollar signs, and then I have height. So what I might want to do as part of a conversion is I might do something along the lines of, say, okay, so if the salary is $1 sign, I'll put a 1. If it's $2 signs, I'll make it a 2. If it's $3 signs, I'll make it a 3. So that I can represent this as numbers. With respect to height, what I might do is to take this and convert it to inches. But I need to do something to align these data formats. Now, we'll see an example here in a second where I'm merging data. And depending on the nature of the different sources of the data, what I might do is I might need to do some type of a conversion so that I can get the formats in the same way. So simple as example, some pieces of equipment may give me distance or temperature or weight in metric, and others may do American Standard. So how do I do that conversion? If something says, oh, it's 5 degrees, well, I've got to know it's 5 degrees Celsius versus 5 degrees Fahrenheit, because those are very, very different things. And if one system reports Fahrenheit and the other system reports Celsius, then I need to do a conversion into one format for the sake of the comparison. Okay, so step 1, we need to remove data. Step 2, we need to align the data formats. Step 3, we need to merge the data sources. So we need to have some key that we're using to do that merging. How do I take some data from some equipment and other data from other equipment? So we're going to look at an example here in a few minutes where we're going to walk through merging two different data sources. And the key that we're going to use today is a zip code. And that was just because it was a convenient thing for me to use. We could have used other things as well. If we're dealing with our telecom equipment, maybe it's going to be things like a cell site ID. Maybe it's going to be something like a user ID. Depending on what we're trying to do, maybe it's going to be something like a piece of equipment ID. Okay, so this is our third step. Remove missing data, align data formats, merge the data, convert strings to numeric. So there's two ways in which we can convert strings to numeric. And we've already talked a little bit about this a couple of slides ago. But what we're really getting at is, in what way should we treat the ordinal and the nominal? So in this case, I've got ordinal data here, and I've got nominal data here. So when we talk about ordinal data, what we're saying is that there's some type of order to it. So in this case, we'll say what we've done is we've awarded badges based off of activity. And we've got a red badge, a green badge, a blue badge, and a purple badge. And the red badge you get first, and after you've done enough activity, you become a green badge, a blue badge, and a purple badge. So kind of has a feeling almost like a karate or a taekwondo belt system, where the color represents an order. So I have a friend who is working on a form of martial arts, and he has just earned his red belt. And so now the next thing he's working on is he's working on the moves that he needs for his black belt. And so his aspiration is to have a black belt, which is the next highest layer, by this summer. So there's an ordinal system. So the way I may convert that, similar to what we did with the dollar signs a couple of graphics ago, is I might say red is level 1, green is level 2, blue is level 3, purple is level 4. In a nominal system, if we do this, it's kind of implying an order that we don't want. And so a lot of times what we'll do is we'll use a different type of conversion mechanism, which is referred to as one-hot encoding. So in this case, what we're going to do is we're going to create an array. And that array is going to be equal to a number of members equal to the number of different objects we have. So in this case, I've got 4 colors, 4 members of the array. And the reason it's called one-hot encoding is because only one value is set to a 1. Everything else is set to a 0. And the one value that's set to a 1 corresponds to the object in question. So for red, we're going to say the first entry is a 1. Blue, the second entry is a 1. Green, the third entry is a 1. Purple, the fourth entry is the 1. So now we're creating a scenario where I don't have an order. I'm not saying red is less valuable than blue, is less valuable than purple. I'm saying that it's red, or it's blue, or it's green. So that's where one-hot encoding comes in. But in either case, what we're able to do now is we're able to do analysis based off of this, because we've gone from some type of string, some type of category, some type of characteristic to numbers. remove missing data, align our data formats, merge our data sources, convert our strings to numerical formats, and last, we might need to do some type of summarization. Now, when we deal with summarization, there's a couple of ways we can do it. I used an example of visualization earlier, but let me give you kind of another way I might use summarization. So in this study, what I've got is I've got a number of people, and I have the number of years they've had their cell phone. Or I've had the number of years that since they graduated college, or I have their age to month and day. So you can see in this case, I've got, we'll say that this is the age of these 6 people. So the lady on the left is 35 years old in 3 months, 26 years and 11 months, 35 and 6, and so on. So there's a couple of ways I can simplify this. One way I could simplify this, which is kind of the obvious way, is I could just convert it to years. So 35 years and 3 months is approximately, I think our math's a little wrong, 35.25 years. 35 and 6 months, 35.5, 35 and 9 months, 35.75. So I could just make it a fraction. Well, here's the question. Do I really care for the sake of the study if someone is 35 and 3 months, 35 and 6 months, or 35 and 9 months? Does that really matter? If it does, great. If it doesn't, then what I might want to do is say, let me break it into buckets. Let me put everybody that's in 25 to 35 years into the same bucket. And then I only need to report which bucket they're in. Maybe it's going to be a wider 85 to 35. Or maybe what it's going to do is it's going to be, well, let's take all of our data and let's break it into buckets representing 20 samples each. So I'll sort this based off of their age, and then I'll take the youngest 20 and put that in bucket 1. The second youngest, bucket 2, and so on, until I've run out of buckets. So depending on the nature of the problem, that may be the best way to solve the problem. When we're looking at a lot of marketing demographics, we don't really want to know if somebody is 57 years old in 2 months. What we want to know is, are they between 55 and 65? So that would be a bucket that we typically see. A lot of them is simply, are you in your 30s, your 40s, your 50s, or your 60s? And that bucket is maybe sufficient versus having to keep the data of 57 years and 2 months. So this is our 5th example. Okay? Before I go into my example that I wanted to show you, are there any questions about cleaning data on a generic level before we jump into actually trying to look at an example? If you do have any comments, please jump in the chat. All right. Excellent. Excellent. So I wanted to provide an example. So before I get into the example, let me kind of tell you the problem that we're going to solve. And so I'm going to draw this out here so you can see this. What I wanted to deal with is I wanted to deal with that burning issue that all of us want to know. And that is, what is the relationship on a per zip code basis in New York State? What is the relationship between the number of crosswalks and natural gas consumption? I'm sure all of you earlier today was saying, I really would like to know what that relationship is? No, you probably weren't. What I wanted to do is to find two data sets that were different in some way, but still had a common key, in this case, a zip code, so that I could merge the data and plot some very basic charts. Where I got the idea, and I was trying to find data similar to this, but I couldn't find it when I was working on this last week. There was a great example that I've heard of, which is a correlation of the divorce rate in Delaware and margarine consumption in the United States year over year. And apparently, and I've seen some charts of it, they match pretty close. And so I was trying to come up with something funny like this. This is what I was able to come up with. A mapping of crosswalks and natural gas consumption. Cool. So what I'm going to do now is I'm going to go into a Jupyter notebook. And if you're not familiar with the concept of a Jupyter notebook, all this is an interactive Python tool. It's a very powerful tool, and it lets me write code and run little code snippets. And so what I've done is I've put together a very, very simplistic analysis to where we can look at this data and walk through how we would clean it, merge it, and visualize something with it. Now, where I got the data was just data.gov. There's nothing magical about the data. This was just the data that I chose. So with all Python programs, the first thing we're going to do is we're going to import a couple of libraries. In this case, all we're doing is importing basic libraries like pandas, which helps us manipulate data. We're then going to load our data into a data frame. And as you can see, this particular data is composed of a number of fields. So it has kind of a city, and it has a kind of a suburb within that city. So the city is represented here, and then this is more of that suburb within the city. So we're going to use the city, the suburb name itself. And you can see that there is the zip code itself. It's dropping the leading zeros just because of the way this data file was set up. And this is the number of crosswalks in that particular zip code. Now, because there's some data that we don't care about, what we're going to do first is we're going to drop some data, and then we're going to rename some columns to where it's a little bit more friendly for us. I don't really care what the original people who use this data, what they called it. I want to do it more based off of what we want to call it. So there is our, I guess it was the city on the left I used, not the city on the right. Okay. So that's my crosswalk data. And this is actually nationwide. I'm only showing you the very, very top of this data. The next thing we have is we have our per zip code consumption of natural gas. And I want you to notice a couple of things about this data. First, notice how I've got some zip codes that repeat. Well, they have a commercial and an institutional and a residential flag that we don't care about. So one of the things we're going to do with our data is we're going to get rid of this type and just sum that up because we don't really care about the individual types. Also notice how we've got this extra piece of information at the end, and we'll see here in a second it's even worse than that. So we need to clean this data by getting rid of that extra stuff to convert it into numbers. All right, so the first thing we'll do is let's remove our unneeded columns, convert our names. So we have zip code, thermal units and GJ units. And I have to be honest with you, I don't know what a GJ unit is, but it's a unit of natural gas consumption. So notice the nature of the zip code. The zip code itself has this extra characters. At the beginning of the file, it's got just an extra couple of characters, but at the end, it actually has tied on the latitude and longitude. So what we're going to do is we're going to clean that. And instead of it being with this extra stuff, we'll just have the number itself. So what I did is I removed the excess stuff we didn't want, and then I converted it to a number. And what you see now is more of the data set. Now, the reason I'm showing you a much larger amount of the data set is, notice here, this is Python's way of showing that there is not data there, non-existent data. I want to remove that. Now, there's a couple of ways I can do it, as we've talked about. What I'm going to choose to do is I'm going to just delete every row from this file that does not have any data. See, there's other examples here. And so I'm going to use a very simple Python command called drop_NA. And so now you can see there are no NAs left. Now, if I go up here, just so you can see the size, what I've done is I've gone from 1,015 rows, that was my original data, down to 1,005 rows. So I've only dropped 10 rows. So it's not a bad thing. Now, the next thing I want to do is, since I have multiple data for a single zip code, let me show you an example of that. And it's not sorted, so it's not the easiest thing to see here. Here's a good one. So you'll notice here, I've got 5 entries for zip code 11400. And so what I want to do is to have a sum of that data. Okay, so I'm going to use another pandas function, another Python function called group by. And so what it's going to do now is it's going to sum up whenever there's duplicates zip codes. It's just going to add all those values together. So now I don't have any of those duplicates anymore. So I've gone from 1,005 to 230 rows. Okay. So we've done a lot of the cleaning so far. We've got our 2 data sources. We've cleaned each data source. And a lot of the stuff I've talked about is really that domain expertise. I've had to research this data and understand what the data is telling me. So now what I'm going to do is I'm going to merge these 2 data sets based off of the zip code. And so I'm going to take the gas consumption, I'm going to add to it the crosswalks based off of the zip code. So that is my new data set. So for zip code 10003, there was that much thermal consumption of natural gas, that much GJ consumption, and there's 33,080 crosswalks. Now, you'll notice a lot of the crosswalks are the same. I think this has to do with if you look, these are all zip codes in Manhattan. So what I think they did is they took all of the Manhattan crosswalks and they divided it by the number of zip codes and they made them the same versus counting each individual zip code. But if you go down farther, they do have different numbers. It seems to be the same for every city. Like, for example, Jamaica, New York has 2 zip codes, and they've got the same number of crosswalks per zip code. So what I think it is it's the total divided by the number of zip codes in that area. So we have 195 rows now. So our data frame is composed of zip codes, thermals, GJs, number of crosswalks, city, and state. So the question that you've been asking the most of yourself, it's a little bit smaller, there it is so what is the relationship? So what this chart is, on the x-axis is the number of crosswalks, and on the y-axis is the natural gas consumption. Cool. Let me pause. Questions, comments, thoughts on our simple little example. I really like this example because it helps me see all of the steps in a more practical way. Data cleaning is a very critical part of any analysis. And depending on the nature of the problem you're trying to solve, which I know I've said that many, many times today, based off the nature of the problem you're trying to solve, it might be in upwards of 70% of your time cleaning your data to prepare it for the study. So I think data cleaning is a very important and lesser understood aspect. And we've had clients that have started down automation projects, and they've come to us and they've said, you know what really stopped us? The reason we didn't finish that automation project, we didn't understand data cleaning well enough. And that was really my motivation for our time together here. So a question, how do you remove outliers? And that's a great question. And there's a number of ways that you can remove outliers. The first way you can do that is you can do some type of an analysis. And let me back up to this slide so we have some real data on the screen to look at. So I could take a study like this, data like this, and I can say, well, let me look at the highs and lows. Let me look at what the range, let me look at the standard deviation. Let me look at the average. And then I can start to decide, there's some data that seems to be more outside of normal, and I can then remove those outliers. What I would do, again, it's going to depend on the nature of the problem you're trying to solve. I would start with, say, I only want to keep the data that's within 3 standard deviations of the mean. If it's more than 3 standard deviations, it's going to mess up my study, and I want to get rid of those outliers. But what you could do is, in the same way that we're deleting a sample where it has no data, I could delete all samples where my total day minutes is greater than 1,000, for example. So no, it's a great question. Great question. Any other questions before we wrap up our time together today? Well, thank you guys so much for spending some time with me together today. I really appreciate it. It's always fun doing these sorts of sessions. Again, as a thank you, I have a discount code for our on-demand training valid through the end of the year. You will get an email from Award Solution once we've published the course material and we have uploaded the recording of our time together today. If you want to reach out to me, the easiest way to reach out to me is via LinkedIn. Feel free to contact me there. My name is Reece. You'll be able to find me, the only one at Award Solutions. And until next time, until next year, you guys have a great rest of 2019, and I hope to see you all again in 2020. Thank you guys very much.